All right, so on page 12, you see we get into something called custom construction parts, finding a pattern. That's kind of the focus of today's lesson is we're finding a pattern. And if you look at the top of your worksheet, we do have a focus question here. Let me drag this down. So it says, how can you predict if a pattern between variables will be linear or nonlinear? So that's something we're going to work today. So in investigation 1, we found stuff that was linear, right? In investigation 1.2, or what we did yesterday with inverse variation, we found stuff that was nonlinear, right? So we're going to see how we can figure that out today by testing a few things. So in this part of your book here, it says, suppose a company called Custom Steel Products supplies materials to builders. One common structure that CSP makes is called a truss. Truss is made in bridges, right? As shown in the figure below, right here. You might see a truss holding up the roof of a building. It is made by fastening together steel rods 1 foot long. So this truss is an overall length of 7 feet. Okay, right here. This is a 7-foot truss. Okay. It says the manager at CSP needs to know the number of rods in any length of a truss a customer might order. So maybe he wants to order a 54-footer or a 40-footer, and we got to be able to come up with an equation that they can use to say, okay, this is the number of rods we need. So take a look at how this truss is made. All right. So the very first part of it is right here, right? I'll use a darker marker here. Right? How many rods assemble that first part of the truss? 3, right? Because they make a triangle, right? Now, to go another foot, right? This is 1 feet. So to go 2 feet, how many more rods do I need to add? 3?
4.
Why 4? Right? 1, 2, 3, and then we got to connect them, right? 4. So the first truss, I added 3 to the first foot, right? The second foot, I added 4. What about if I wanted to go 3 feet? Add 4 more. 1, 2, 3. So you kind of see a pattern there, right? So with your group, I'm going to get rid of this guy because we don't need that anymore. All right, so the table's been copied for you. What your goal is to do for, we'll say, the next 10 minutes, we'll check in with you in 5 and see where you're at. But I want you to fill in those missing values of the table and make a graph of those points. Once you make a graph down below where number 2 is, describe the pattern of change in the number of rods used as the truss length increases. And be ready to let me know if this is linear or nonlinear. Okay? So you guys got, I'm going to check in with you at 8:35, give you guys 5 minutes. All right, go ahead. All right, so what did you notice about the table? Blake?
It goes up, well, for every foot, it goes up 4 rods.
For every foot, it goes up 4 rods, right? Because that's what we showed that, every foot we add on to the first one, we added 4 rods, right? So you should have 15 here, 19, 23, 31, right? Is that what everybody had? Going up by 4? And again, you could have counted them too. All right, so if you made your graph, just by looking at the table, what could you tell about this? Would you say linear or nonlinear?
Linear.
Why?
Because it has a constant rate of change.
Where?
It keeps going up at first.
Right. Yeah, this one here increases by 1 every time, right? Oop. Let's try that again. There we go. Right? And up here, we're plus 4, every single time. And again, a constant rate of change means it's the same every time. So it's that same 4-to-1 ratio every single time, right? So if we were to graph this, this should look like a straight line, right? 2, 3, 4, 5, 6, 7, and I think I'll go up this by 5s. So this is our number of rods. Make sure you're labeling your axes. And this is the length of the truss. And that's in feet. So at the first foot, we're at 3, and then 7, and then just trying to graph the best I can here. And
if you didn't count by fives, it's not wrong. I counted by fours because it's increased to fours. As long as it's a consistent pattern on that y-axis, you're okay.
right? So we can all agree that that's linear, right? All right, so how would you describe the pattern of change then? You can use the table to graph pattern of change. Basically, how does the rods change as the truss length increases? How would you say that, Angelina? That's a very good sentence. So as the truss length increases, the number of rods increases by 4. So for every foot added on, we increase by 4 rods. Pretty straightforward, right? Okay. Now here's where the thinking's going to start to come in. We've kind of laid our groundwork here, right? So if you go to the back page, how is the pattern you described shown in the table? Okay. Well, again, how do you see that? As the foot increases by 1, the rods increase by 4. You see that in the table, right? You see your Y column, your rods. Your number of rods goes from, where's my table side again? I flipped my page over. So the rods go from 7 to 11 to 15 to 19 to 23 to 27 to 31, right? That's where it's shown, right? That bottom count, that bottom row. And that's an increase of 4 every time, right? And up top where the truss length is, right? We go from 1 to 2 to 3 to 4 to 5 to 6 to 7. So that's increasing by 1 and that's increasing by 4, right? That's where you see in the table. It's pretty easy to see in the table, right? How do you see it in the graph then? How do you see that increase in the graph?
It has a steady line.
Yeah, it's a straight line, right? You see the straight line? It goes up by 4 and over 1 every time, right, on the graph? Up 4 and over 1, up 4, because that's our slope, right? All right, so here's where we're going to put it all together. You don't have a 50-foot truss, do you? So here's how you're going to have to figure this out. How many steel rods are going to be in a 50-foot truss? Explain how to find this number without drawing the truss. So they don't want you to draw a 50-footer. They gave you 27 feet, right? They showed you, or sorry, they showed you a 7-foot truss had 27 rods, right? So now you got to figure out 50. So we got to try to see if we can find that pattern. All right? And I want to give you guys 5 minutes to talk about this. So in 5 minutes with your group mates, see what you guys can come up with in terms of, if I were to ask you, if your boss, if you're working for this company, you know how many rods are in a 7-foot truss, and now your boss comes to you and say, hey, listen, we need a 50-foot truss. I need to know how many rods we need for this. Okay, we got to order it right now. You should be able to tell them. So see what you guys can figure out. I'm going to give you guys 5 minutes to work on this. All right, we're gonna dial it back in here. All right, so I saw groups that had, how many groups had 200 rods? Nobody?
We basically
You guys had 200 rods? Okay, so we got one group with 200. I saw, how many groups have 199? I saw some groups with that. And then I think I saw 195, right? How many groups have 195? Did anyone have anything different than these three answers? Nothing? So it's one of those three possibilities, right? All right, so let's talk about it.
go.
So, anyone want to take a shot at explaining it? This
You
group
said
here,
that
okay.
4x minus 199 and the x equals 50. So 50 times 4, which is
All right, so you said 4x minus 1. All right, so let's talk about how you got that. How'd you get 4x? What thought process gave you guys to 4x minus 1?
um,
Just the whole group. You guys kind of were figuring this out, right?
we saw that the constant rate change is 4, and so I did. You had to add
All right, hold on. That's a great. The constant rate of change is 4, right? We saw that in our table, right? Every time we added a foot, how many rods were added?
4,
4. Okay, so that's where that number comes from, right? What's our x?
50.
No, not well. But what does our x mean in terms of the variable? If we were to define the variable, that x means what? The number of feet, right? The length of the feet. So if we wanted a 50-foot truss, we would have to plug 50 in. If we want a 25, right, to x. So where does the minus 1 come from then? Because this part makes sense to everybody, right? Does the 4x make sense to everybody? That makes sense, right? We saw that in our table. We saw that on our graph, right? So where does the minus 1 come from then, guys? So at the beginning, we only went up 3. Well, we only started with 3, right? The 3, and then we added a foot, and that was 4, and then 4, and then 4. So we only started with the 3. So that minus 1, because isn't 3 compared to 4 a difference of 1?
Yeah.
So you had to take that first foot out. This was kind of like that problem the other day. Remember when I put the minus 1 in, and you guys were like, what? That first foot only has one less rod. So if we take that out, okay, and plug 50 feet into this, you get 200, and then when you subtract 1, it is 199 rods. Very good. Now, even though people that, 200, this is the easy, because you think, okay, 50 feet, 4 rods, 200. You just forgot that first one, but your method of thinking was good. And these guys here, when I was talking with them, you guys were really close, just a couple things, but I liked the method of thinking. I liked all the conversations. I thought they were really, really good. You guys are really putting your heads together with that. Because it's not an easy problem. You're looking at that truss, and you're just, right? You really got to think deep into it. But that's it. That's our little equation, is 4x minus 1. All right, and we can obviously add the y equals, because this y is going to be our number of rods, right? That's our total. And our x, we know, is going to be our feet. 4 is our constant rate of change, and minus 1 is the rod we're missing from the first foot. And that's how they came up with that equation. So very good job to everybody. All right, we're going to start on part B here. So now your boss isn't satisfied with the truss. You guys also make staircase frames, right? If you've ever seen them build a house, you said they build a staircase. They just don't put the steps in one on top of the other, right? You got to be able to fasten them to something. So they build a staircase frame. So it says step 1 is made out of 4 rods, right? You see that? 1, 2, 3, 4. Well, in step 2, it's made from 10 rods, right? Because if you look here, there's 4 here, right? From the first one, and then 1, 2, 3, 4, 5, 6. So we had basically had to add 6 more rods to get to 10, right? And then so on and so forth. So now your task is, just in part 1, and if you get done with one quickly, 1 and 2, is complete your table and see how this compares to the truss and graph it and see if you see any differences. Okay, I know we only got about 7 more minutes of class, but Take a look at 1 and 2 in part B and see how the staircase frame compares to your information that you did with the truss in part A. All right? And try to see if you can find the pattern as we go from 4 rods to 10 rods to 18 rods. Talk to each other. Go.